Let's start this session using plot. Like we'll be plotting some responses. So first step, we'll be clearing the workspace and the screen. So CLC, clear all. And in earlier session, we know how to define an array. So let's take a variable theta equals, or let's say t equals 0 colon pi. It refers to initial 0, final pi with step size of 1. So in default, we have a size of 4 elements. So let's try modifying the step size to pi by 10. So including 0, it will have 11 elements. Yes, we have that 11 elements. So most of the time you may see, or in help command if you go, you have another way of defining this array. They use linear space. So lin space is a function. So in Matlab, we have already discussed, any function will be defined in round brackets. So lin space and round brackets. And inside we'll have to mention its input arguments. That is 0, that is initial, final, and how many equal spaces or linear spaces you want. Let's say 10. Let's modify 11. Let's check whether it is giving the same answer. Yes, it gives the same. So let's proceed towards the plot. So mostly we'll be using linspace command. So clearing the screen, but if you note in workspace, we still have that variable t. So, and we will suppress that value in display command. And let's define y as a dependent variable on t. Let's say 2 into sign. Sign is a function, so round bracket. And inside we'll define t. So y also becomes an array dependent on t. So again, we'll be plotting these two responses on x and y. So plot will be having command like x comma y. Plot is a function, so plot and round bracket. So we'll be having x argument and y argument, but here x argument will be t. So we'll replace that x by simply y. So its syntax is plot independent comma dependent variable. So there we go. Now we have the plot or response of the array we have just appended now, y and t. But here, if you know, like if you just magnify that points or the area, you may directly see it's discretized. So, and with cursor, if you move, it gives only 11 elements defined in that period. So in order to remove that kinks introduced due to small spacing, will increase our independent variable size. So let's make that 11. And let's increase the range also. And let's increase the spacings to, let's say, 100. So in workspace, if you note, size became like 1 to 100, like 100 elements between 0 to 4 pi. And similarly, we'll have to modify y, because y both should be of same size, else plot command will give an error. And using up cursor key, we'll directly call that plot command. And there we go. We have final result. Like we have a smooth, almost smooth sinusoid curve. And we can utilize some inbuilt commands like grid on, which is specifically for figure. Like if you know that figure file, so it's one of the files which we can directly create. We have seen how to plot the desired response. Now we'll see how to write a script file for plotting the same, what we did earlier. So there are various types of files or models you can create using Matlab. So we'll be choosing for time being a script. A script is an editor in which we can write programs. And when you execute it, Matlab compiler executes, or Matlab compiles the codes which we write in this editor. So let's begin the process. So we'll be adding that attributes CLC and clear all for clearing the screen and workspace. And same as we have mentioned for the independent variable t, linear space. And then we'll define a dependent variable, let's say y equals 2 sine t. So now we have this independent and dependent variables. So let's proceed to plot. So again, plot is a function. So plot around bracket, and inside we'll have an attribute. So before proceeding any further, we'll save the file and this. So and one point to be noted is like your file name shouldn't begin with a number, and your file name shouldn't contain any spaces or a special characters other than underscore, else it will generate an error, and its extension will be .m. So let's execute it. So that green tab which we are seeing, if we just execute it, we'll have the output response, and it will ask for change the folder. So confirm with the same, and here we have the plot. So the basic or the idea of using script file is that it provides much more variability than using in command window. Likewise, we can change any parameters like the time scale range or the amplitude range, and we can save it, like we can grep it and save it, and we can add on or modify various parameters related to the plot or the figure command or to the figure file. For an example, like using plot like t, y, the third attribute that is assigned for color, we can change it. So it's a dynamic file, we can say. So we'll see later on much more insight.